Hey, Top Airlines Math and History, and we are going to learn about calculating the angles on a clock. Or should I say, it's time to learn about angles on a clock. So what we're going to basically be doing is we're going to be using degrees, minutes, and seconds to find out how long it takes for the clock to get that much degrees. Because if you notice on a clock, an analog clock, you see an hour hand, a minute hand, and possibly a second hand. The thing is, those hands that are constantly going around 24/7 actually make up angles of themselves. Here's an example. We have one line and we have two lines. Since this is an hour hand and this is a minute hand, or it could be one or the other, they make an angle. So, when we saw the movements of a clock, we saw that it does make an angle. So, to understand and calculate the number of degrees and the time it takes to do so, there are some things that we kind of have to know about. The thing is, if 12 hours is represented on a clock because there are numbers 1 through 12, and a clock has to go around itself 2 times per day, that's why we have AM and PM. If a 12-hour clock is equal to 360 degrees, because 360 is one rotation, then 1 degree is equal to 60 minutes, because 60 minutes is equal to an hour, which is equal to 360, that has 12 hours. And 1 minute equals 60 seconds. So, if 12 hours equals 360, 1 degree is 60 minutes because that is 1 hour. And 1 minute equals 60 seconds. So, that is basically what we have to know about. We have to know about the number of degrees. The minutes have passed, and the seconds have passed. The thing is about degrees, it cannot exceed 360 degrees in this video. So, the kind of answers that we're going to look at is going to come in this format right here. So you'll see degrees as a degrees symbol. Minutes, they'll have 1 strike right behind the number, and it'll always be the middle number. And seconds will have 2 strikes, and will be the last one. Here's an example when we are talking about degrees, minutes, and seconds. So, we have, if a clock has hands that make an 84-degree angle, and it's 30 minutes, what we're going to have to do with this is we don't want minutes right now. What we're going to try and do is turn it into a fraction. So, if we have 60 minutes in a single hour, and we have 30 minutes on the top for this problem, we can simplify that to a fraction of 1/2. So, when a clock has hands made up of 84 degrees, it will have 84 degrees and 1/2. Or 84.5 if you're looking for a decimal. That's one way. Let's look at another example. So imagine this time. So if we have a clock that makes up an angle that's 10 degrees with its hands, and it has 20 now if it has 15 minutes, what we want to do is we want to leave the number of degrees. What we got to actually deal with is the measurement of the time. We have to turn it into a fraction. So 15 minutes and an entire hour is 60 minutes. We can simplify that to 1 over 4. So 10 degrees, 1 over 4. Or some teachers want it as 10.25 degrees. So these two examples are examples when you want to have the measurement of a time turned into a fraction. But sometimes your math teacher might want you to do it the opposite. If we had a time, if we had degrees and a fraction, and your teacher wanted to put it in time, we sort of have to do things a little bit backwards. Well, yeah, it is about backwards and doing it in reverse. So imagine we have 60 degrees, a clock that makes 60 degrees, and it has 3 over 4 as a fraction. What is the time? So we leave the degrees right here, and we have to handle the fraction and turn it into minutes. If we look at 3/4 of a clock and we draw a diagram, this is basically 3/4 right here. So we can say that 60 degrees and 45 minutes. So that is a really good warm-up because in geometry, you'll have to know about these angles and you'll have to know about these minutes and seconds when you're solving these kind of problems. So this one was changing a fraction back to time. Now here is the problem that we're going to be challenging you guys and gals about degrees, minutes, and seconds. So here is our example problem. This is what is given to us. So here's what's given. If angle ABC is a right angle and is 90 degrees, and the measurement of ABD is 67 degrees, 21 minutes, and 37 seconds, what is the measurement of DBC? So we're in sort of a little problem because it's giving us the degrees, the minutes, and the seconds for angle ABD, and what we want to try and find is right here, the angle of DBC. So basically, we have to understand that angle ABC is a right angle, and ABD is this thing right here. Therefore, what we can do is, if we want to find DBC, we have to subtract ABC by ABD. So here is ABC, and we have to subtract that by ABD. The measurement for ABC, since it's 90 degrees, we're going to say 90 degrees, 60 minutes, and 60 seconds, referring to our format for our answers that we want. So this is what it looks like. And for the other one, 67 degrees, 21 minutes, and 37 seconds goes right under here. So now what we have to do is we have to subtract the two. So the way we subtract the two is very similar to the subtraction algorithm method. So do you remember in your younger years of mathematics where you had to subtract 12 by 9, or if you had to subtract by what should we say, 36, and we should say 19. Well, we do the same thing with this one, but instead of starting from the right, we have to start from the left, since we have degrees that can be transferred to minutes, which can be transferred to seconds. So starting out here, since we have a 0 and a 7, we want to change it down a bit. So cross out that 90 and turn it into an 89. So now we say 89, subtract that by 67, that will be 22 degrees. Just like this one, the 60. You don't want to have a 0, so basically, we're going to put it into a 59. Cross out the 60 minutes. Now 59 minus 21 is going to be 38. 38 minutes. And this one you can leave okay. And that just becomes 23 seconds. The reason why we just did that is instead of starting at the right, we start at the left. But we have to go toward the right last remaining digit of that number. Then we subtract in 3 parts. 1, 2, 3. So by subtracting ABC and ABD, we'll be able to get DBC. And guess what we got? We got this as a measurement right here. So we have 22 degrees, 38 minutes, and 23 seconds. That is our measurement for angle DBC. So now we figured out what that question mark was. If we have subtracted them, we can also add them too. But adding can be a lot easier. Here's an example. So we have to add 37 degrees, 15 minutes, 28 seconds, and 41 degrees, 16 minutes, and 37 seconds. But we do it just like we're subtracting. But this time, we do the same method by adding. So we start at the first number on the left, with the digits right here. So, 7 plus 1 is 8. And 3 plus 4 is 7. 78 degrees. With the minutes, 15 minutes plus 16 minutes is 31 minutes. And for this one right here, 28 seconds plus 37 seconds is going to become 65 seconds. But there's a problem. A clock can only have 60 seconds in 1 minute. Therefore, we're going to have to do some tributing. And we're also going to have to do some carrying. Since the 65 can have an entire 1 minute right here, we can cross out the 6 and turn it into a 0. Now we have to add by 1 onto the 31, indicating that we took away 60 seconds to add 1 minute into the minute section. So here's our final answer. 78 degrees, 32 minutes, because we added that plus 1, and 5 seconds. That is how we can add them too. And that is also how we can understand the angles on a clock. This can also be known as DMS notation, because it studies degrees as D, M as minutes, and S as seconds. DMS notation. I hope this video has helped you understand the angles on a clock. Thank you for watching Taoping Your Life's Math Industry. Like and subscribe.